Hey, what is going on? It is me, and it is Wednesday, February 16th, 2022. And today I am doing a Leetcode coding question, um, number 455, assign cookies. Okay, so this is marked as an easy question, and I liked this question. It has more likes than dislikes. That's good by a factor of almost 10. So, yeah, people must find this pretty intuitive. So, the question states, assume you're an awesome parent and you want to give your children some cookies, but you should give each child at most one cookie. Um, each child I has a greed factor G of I, so there's an array of children. Uh, if this is your greedy children, it's 1, 2, and 3 here, and which is the minimum size of a cookie that the child will be content with. And each cookie j has a size s of j. If s of j is greater than g of I, we can assign the cookie j to the child I, and the child I will be content. Your goal is to maximize the number of your content children and output the maximum number. Okay, so um, so the example that's given is that you have 1, 2, 3, and you have 1 and 1, and your output should be 1. You have 3 children and 2 cookies. The greed factor of 3 children are 1, 2, 3, and even though you have 2 cookies, since their size is both 1, you could only make the child whose greed factor is 1 content. You need to output 1. And that makes sense, right? Because you have only cookies of size 1, and you take a cookie of 1 and you give it to the greedy child of 1, that strikes this greedy child off your list, and you only have a cookie of size 1 left, and you can't satisfy either of these children, right? Because you have one that needs 2 and 3, so you don't most take 1 off their greed factor. Um, so that's a simple example. Another simple example is the next one, where you have 1 and 2 and for your children, and you have 3 cookies, S1, 2, and 3. And the most children you can satisfy is 2 children, because you have a child of size 1 and 2, and you have a cookie of size 1 and 2. And so you'd be able to satisfy every child in the array, right? So some key things to think about when trying to solve this problem. You can only assign the cookie j to the child I, and the child I will be content. What does that mean? Um, well, so yeah, you can assign one cookie, right? You should give it each child at most one cookie. So you can imagine that you would have a situation where you could have S having 1, 1, 1, 3, 1, 1, 1, 3 cookies here, and you have 1, 2, and 3. You still can only satisfy one child, because you have a cookie of size 1, and that will be given to one child. You'd still have 2 more cookies of size 1, but you can't give them both to child 2. You can only give one to child 2 to satisfy child 2. So therefore, you could still only satisfy one child. The problem could be augmented to be like you can give multiple cookies to a child, and then the program would be, I believe, exponentially harder to solve. Not in time complexity, just in just complexity. It would be more, maybe time complexity, who knows. It would be a much more involved problem to solve, but the constraint that you can give it each child at most one cookie, really, at most, really makes this problem simpler. So what can you do here? How would you solve this problem? So basically, let's think we have arrays, and this is basically a greedy problem, right? Like, I mean, the hint is in the name of the problem. So what should we do? Well, um, if we have one child 1, 2, 3, right, and we have 1 and 1, right, that we can order these cookies and we can order these children in the order of their greed and their size, respectively. And they're already in this array ordered that way. But what that allows us to do is quickly strike out children, right, and satisfy them with a cookie, right? And if it's not possible, then they won't get counted. But these 2 zeroed out elements, we're not going to zero out elements, but this is for illustrative purposes, get counted out. And so, like, for example, let's say if I extended this array, right, and I had 2, 2, and then 4, right? What would I do here in this situation? Well, satisfy the first child again, right? Satisfy the second child, right? And then I'd go to the next child, next cookie, and I see that I can't satisfy this child, right, with this cookie, so I'll have to go to the next cookie, right? And I can satisfy this child with the cookie. And I can pretty much straightforwardly increment the size of this secondary array whenever I find a child that can be satisfied with the cookie size, and if not, just simply ignore it, right? So 4 was greater than 3, so I was able to satisfy that child by giving him this cookie of size 4. And the only way I could do this confidently was that I ordered these elements, so I know that I can always go to the next cookie and it could be greater than or equal to. It'll never be less than the previous cookie. So it'll have more satisfiability than the previous cookie. So that gives me an algorithm I can work with, right? So the first thing I do is erase that sort G. We're going to sort, remember we talked about this, we're going to sort the two arrays, sort S, okay? That gives me the two sorted arrays. Now we're going to talk in terms of cookie, right? Child. Let's name our variables appropriately. Those are how we do well in interviews. And now we want to loop through the children and the cookies, right? So print I equals 0. Let's loop through the children. The cookies. Child. Let's use these more. Less than s dot length cookie less than s dot length and cookie plus plus. Okay, so what can we do now? Now remember, we want to only satisfy the child, right? If we have a cookie, right? If child is less than g dot length. Let's put this first because we don't want to go outside the bounds of the children's array. If s of cookie is greater than or equal to g of child, okay, right? Then what do we do here? Then if that's the case, remember, if we are able to satisfy the child with the cookie because it's larger than the size, then we can move the total number of cookies. We can increase the total number of cookies, and we can move effectively to the next child, right? You go to the next child because the previous child is already satisfied. If this condition doesn't hold, right, we're not going to increment this next child. We simply and we don't increment the total, we simply move to the next cookie. And we go all the way, and we can possibly get to through all the cookies and not satisfy a single child, in which case the second inner child variable wouldn't be incremented at all. We'd still be stuck trying to satisfy the first child. So by the time we get to the end of that array, right, we return total. And I believe it's as simple as this. I forgot to create my total variable. And there you go. Solves that. Let's just see if we could solve the next case. So yep, solves that. Now solves both test cases, and yes, that solved that problem. So there's probably faster ways to do this. Maybe there's ways to do it without sorting. I don't know, but the runtime of this is n log n, right? Because we have the sorting, which is it's n log n, so it would be whatever is greater, g log G or S log S, the size of either S or G, right? And that would dominate this outer factor here, which is a linear scan. So that's pretty much it. Like, subscribe, and do all that good stuff. I'll see you around.